Video podcast for the final for the Chapter 4 problems. Starting with 47, the General Social Survey, conducted by the National Opinion Research Center at the University of Chicago, is a major source of data on social attitudes in the United States. Once each year, 1,500 adults are interviewed. Let's grab some cover sheets here. In their homes all across the country. The subjects are asked their opinions about sex and marriage, attitudes toward women, welfare, foreign policy, and many other issues. The GSS began by selecting a sample of counties from the 3,000 counties in the country. The counties are divided into urban, rural, and suburban. A separate sample is chosen at random from each group. This is they're separating them kind of by type of county and then sampling from each. So that is a stratified random sample. Next, 48. The web portal AOL places opinion poll questions next to many of its news stories. Simply click your response to join the sample. One of the questions in January 2008 was, do you plan to diet this year? More than 30,000 people responded, with 68% saying yes. You can conclude that about 68% of Americans plan to diet. Well, that's generalizing for all of Americans based on this one voluntary response sample, so no. The poll uses a convenience sample. Well, it's not a convenience sample. It's a voluntary response sample, which is also a problem. Different kind of problem, but it's a problem. So that is the issue there. Choice C is correct. Too small to draw a conclusion isn't an issue here. It's the method that was the problem. Archaeologists plan to examine a sample of 2-meter square plots near an ancient Greek city for artifacts visible in the ground. They choose separate random samples of plots from floodplain, coast, foothills, and high hills. What kind of sample is this? Well, again, they are choosing random samples from within these different areas that have something in common based on the type of ground it is. So when they sort that way, that is another stratified random sample. 50. When we take a census, we attempt to collect data from who? We'll just read carefully. Some people read every individual and then they kind of start circling, but it's not every individual in an SRS, it's every individual in the entire population is a census. So 50 is C. 51. A consumer product agency tests miles per gallon for a sample of automobiles using each of 4 different octanes of gasoline. Which of the following is true? And it's basically about explanatory variables and levels and stuff like that. And because they're testing all gasoline, but 4 different kinds, this is 1 explanatory variable, but 4 levels of response. So B is the correct choice here. 52. Corn variety 1 yielded 140 bushels per acre last year at a research farm. This year, corn variety 2, planted in the same location, yielded only 110 bushels per acre. Unfortunately, we don't know whether the difference is due to the superiority of variety 1 or the effect of this year's drought. What is this an example of? Well, anytime you have 2 different variables, the one they were testing was the corn variety, but the one that they weren't necessarily trying to test was the drought. Anytime you have 2 variables that you can't differentiate between, that is confounding. So C is correct. 53. A double-blind experiment was conducted to evaluate the effectiveness of the Salk polio vaccine. The purpose of keeping the diagnosing physicians unaware of the treatment status of experimental subjects is to what? Well, it's not to eliminate the grounds for malpractice suits. Ensure that the subjects were randomly assigned. No, double blind doesn't have to do with random assignment. You can have a lack of blinding where the physicians know what they're getting but still have those treatments randomly assigned. C, eliminate a possible source of bias. This is our answer. And it could be conscious or it could be unconscious, but if the researchers know who's getting what treatment, that might affect how they either hand it out or how they interpret the results. So C is what they're shooting for. Make sure nobody's harmed. No, that doesn't have to do with blinding. And placebo effect isn't going to be helped by blinding, keeping the physicians unaware. The blinding on the end of the experiment, the subjects is for the placebo effect, but they ask specifically about keeping the diagnosing physicians unaware. So C is still correct after further explanation. 54. A report in a medical journal notes that the risk of developing Alzheimer's disease among subjects who voluntarily regularly took the anti-inflammatory drug ibuprofen was about half the risk among those who did not. Is this good evidence that ibuprofen is effective in preventing Alzheimer's disease? Well, the way they got this data was by I was looking for voluntarily. The fact that they voluntarily regularly took it means that it was not assigned to them. This was not a treatment, which means it's not an experiment. So we are looking at no, because this is an observational study. So we would need to do an experiment before we could make that claim. 55. 2 essential features of all statistically designed experiments are what? To be perfectly honest, this is one where I debate a little bit with where this. I try to always pull our questions from other sources of AP material, and I disagree a little bit, or at least think there might be 2 answers. So the big idea that the essential features after are control, randomization, replication, the big 3. So like choice A, it's not that double blind is bad to have, it's good to have, but it's not essential. So that's the way we throw that out. The one that is intended to be the correct choice, and is probably the better choice, but is compare several treatments and use chance to assign subjects to treatments. C, always have a placebo group, use the double blind method. Again, this double blind issue, that's not essential. Use a block design, definitely a block design isn't essential. This is the one that I guess it kind of depends how you interpret it. Using enough subjects is definitely essential. That's replication. It's the control group one. We always have to have control. We always have to have comparison. Technically, you don't have to have a control group. If you're testing 200 milligrams of a drug and 400 milligrams, then there is no control group. So I guess I misspoke before. I don't disagree that B is the correct choice, but if you interpreted this as just meaning we need to have control in general, then it would be true. A control group is something slightly different. That's a group that's receiving a placebo or receiving no treatment at all. So it's just more of a parsing of the language. So if you said E because you were thinking control, you're on the right track. Control group is kind of a different thing. 56. You want to take a simple random sample of 50 of the 816 students who live in a dormitory on campus. You label the students 001 to 816 in alphabetical order. On the table of random digits, you read the entries. And the first 3 students in our sample would have what labels? As I start looking at these, the first 3 is 955. That's above this, or outside that range. 929, same thing. My first student would be 400. Then 769, still in my range. 769, I'm not going to repeat here because I am taking a sample. When we talk probability and random number generators and stuff, that would be different. We can have repeats there, not when we're drawing a sample. So my third and final number is 335. That list of combinations is choice E. 57. Consider an experiment to investigate the effectiveness of different insecticides in controlling pests and their impact on the productivity of tomato plants. What is the best reason for randomly assigning treatment levels, spraying or not spraying, to the experimental units? So basically, why do we do random assignment? And the answer is this. We kind of we talked about this, with the reasons why for each of the big 3. Random assignment is all about averaging out uncontrolled little differences among things that are among our experimental units. So soil fertility is one, and we want by randomly assigning, we kind of it should help balance out all those other factors. So 57 is B. Two more on this part of this page. 58. The most important advantage of experiments over observational studies is... This is one of those big ones. Definitely make sure you're aware of this. Experiments can give better evidence of causation. Generally, we can't use observational studies to necessarily prove causation. The major exception that we'd be all familiar with is smoking. Eventually, there's been so much observational study evidence that it's pretty established that smoking is bad for you. But technically, there wasn't necessarily ever experiments done with humans to verify it for ethical reasons. So experiments, the big difference is experiments can give better evidence or give evidence for causation, and observational studies cannot. A TV station wishes to obtain information on the TV viewing habits in its market area. The market area contains one city of a population 170,000, another of 70,000, and 4 towns of about 5,000 inhabitants each. Which of the following sampling designs would give the type of information that the station requires? Well, if they think there might be a difference among those different sized towns, then a stratified sample is what they're going to want to do. Then they'll get some data from each of those areas, and then they can compare the results once they have all the data. 2 to go in Chapter 4. Bias in a sampling method is any error in the sample. No, a bias is not an error. Or like at least how they have it described here, a deviation of the sample result from the truth. That's not bias. B, the random error due to using chance to select a sample. That's also not bias. C, any error due to practical difficulties such as contacting the subject selected. That is not bias in the sampling method. That's getting on the idea of non-response, but that's not bias in the method. Bias in the method is any systematic error that tends to occur in the same direction whenever you use the sampling method, where we systematically favor certain outcomes or a certain direction to what's going on. E is one they always throw in there to make sure you understand the difference between like racial bias or gender bias versus bias in statistics. Last one from Chapter 4, 61. You wonder if TV ads are more effective when they are longer or repeated more often, or both. So you design an experiment. You prepare 30-second and 60-second ads, and your subject will all watch the same TV program, but you assign them at random to 4 different groups. One group sees the 30-second ad once during the program, another sees it 3 times, the third group sees the 60-second ad once, and the last group sees the 60-second ad 3 times. You ask all the subjects how likely they are to buy the camera, and basically you want to pick what kind of experiment it is. It is not a matched pairs design. And in the end, it is and it's not a randomized block design. This is a completely randomized design, and they've actually got 2 explanatory variables. One is commercial length. The other is number of times watched. So D is the correct answer for the final question from Chapter 4. Hope that helps. Same old, same old. If you do have more questions, feel free to email or come and find me.